Crude oil, often called black gold, begins its journey deep beneath the Earth's surface, formed over millions of years from the remains of ancient marine organisms. These organic materials, buried under layers of sediment and subjected to intense heat and pressure, gradually transformed into hydrocarbons, the building blocks of oil and natural gas. Once extracted through drilling, crude oil is transported to refineries, where its transformation into usable fuels like gasoline, petrol, and diesel begins. This process is both a marvel of engineering and a testament to human ingenuity, involving complex chemical reactions and precise control over temperature and pressure. At the heart of refining is a process called fractional distillation. Crude oil is first heated in a furnace until it vaporizes. The vapor then enters a distillation column, a towering structure where temperature decreases as you move upward. Inside this column, the vaporized hydrocarbons separate based on their boiling points. Heavier components like bitumen and lubricating oils condense at the bottom, while lighter fractions such as gasoline and diesel rise higher before condensing. This separation is crucial because each fraction has distinct properties and applications. Gasoline, for instance, is composed of smaller hydrocarbon molecules that ignite easily, making it ideal for internal combustion engines in cars. Diesel, with its longer carbon chains, burns more slowly and efficiently, which is why it's favored for trucks and heavy machinery. But fractional distillation is only the beginning. To meet modern fuel demands, refineries often use additional processes to modify and enhance these fractions. One such method is catalytic cracking, where heavier hydrocarbons are broken down into lighter ones using heat and catalysts. This increases the yield of high-demand products like gasoline. Conversely, hydrocracking uses hydrogen and catalysts to achieve similar results, producing cleaner fuels with fewer impurities. Reforming is another key step, where low-octane hydrocarbons are restructured into high-octane compounds, improving the performance of gasoline. These chemical transformations are essential for tailoring fuels to meet specific engine requirements and environmental standards. Once refined, fuels undergo blending, where additives are mixed in to improve performance, reduce emissions, and enhance stability. For gasoline, this might include detergents to clean engine parts or ethanol to increase oxygen content and reduce carbon monoxide emissions. Diesel may be treated with anti-gelling agents to ensure it flows smoothly in cold temperatures. These additives are carefully calibrated to meet regulatory standards and optimize engine efficiency. After blending, the fuels are stored in tanks and distributed via pipelines, trucks, or ships to gas stations and industrial facilities, ready to power the world's vehicles, generators, and machinery. The journey from crude oil to fuel is not just a technical process, it's a global enterprise. Refineries operate around the clock, processing millions of barrels each day. Engineers monitor every stage, ensuring safety, efficiency, and compliance with environmental regulations. The fuels produced are tested rigorously for quality, and any deviation can lead to costly recalls or engine damage. Moreover, the refining industry is constantly evolving, driven by innovations in chemistry, automation, and sustainability. New technologies aim to reduce carbon emissions, improve energy efficiency, and even convert bio-based feedstocks into renewable fuels, signaling a shift toward greener alternatives. Despite its complexity, the refining process is remarkably efficient. A single barrel of crude oil can yield multiple products: gasoline, diesel, jet fuel, kerosene, and even petrochemicals used in plastics and pharmaceuticals. Each product has its own market, its own value chain, and its own role in modern life. Gasoline powers personal mobility, diesel drives logistics and agriculture, and petrochemicals form the backbone of countless consumer goods. This versatility makes crude oil one of the most economically significant resources on the planet, underpinning industries, economies, and daily routines. Yet, the story of oil is also one of environmental impact. Burning fossil fuels releases greenhouse gases, contributing to climate change. Refineries themselves consume vast amounts of energy and produce emissions. As a result, there's growing pressure to transition toward cleaner energy sources. Governments and companies are investing in electric vehicles, hydrogen fuel cells, and carbon capture technologies. Still, Oil remains deeply embedded in global infrastructure, and its transformation into fuel continues to be a cornerstone of industrial civilization. In essence, the conversion of crude oil into gasoline, petrol, and diesel is a symphony of science, engineering, and logistics. It begins with ancient organic matter and ends with the fuel that powers our lives. Along the way, it passes through furnaces, columns, reactors, and pipelines, each step meticulously designed to extract maximum value from every drop. As we look to the future, this process may evolve, but its legacy will remain, a testament to how humanity learned to harness nature's buried energy and turn it into motion, progress, and possibility.